Okay. So, any doubts so far based on whatever we discussed so far? Whatever the service we have completed yesterday? Hello? Am I audible?
28, 22.
28, 22,
22, 19,
19.
10, 11, 14,
I'm just asking about yesterday's one, 14.
14,
How about 2E? What is 2E? That status byte covers in 19 service only. It is just a 1 byte of 19 service. How about 2E? What is 2E for?
write data,
Sorry?
write data,
Write data?
by identifier.
by data by identifier.
Very good. Write data by identifier. Okay, so these many services, yesterday only we have discovered these many services. So overall, how many services we have covered? 10, 11. Give me a second. Nishma? Yes, please come on. How many services we have completed so far?
10, 11,
Uh-huh.
27,
Uh-huh.
22, 2E, 14, 19,
Mm-hmm.
Total 7 services.
28,
Mm-hmm. That's it. Ten, 11, 27, and then 28, 22, 2E, 19, 14, multi-frames. And what else we have covered?
False also. False.
That covers in 19 service only, no? Okay, so these many topics we have covered so far. So I have left out with a few more services which we will be discussing today. So the first one is 85. Since we have already covered 14 and 19, I would like to cover first 85 service. So any idea, anyone knows what is 85 service is for?
control DT setting.
Control DTC setting.
So what is that meaning, control DTC setting?
I control data trouble code setting.
Yeah, you are just, told the expansion of DTC, nothing else. So I asked, what is it meaning? Okay. So as we know, how we get this, information from the ECU? By using which service we get the information about the DTCs? 19 service, right? If you request 1901, you will get number of faults which has been set. If you request 1902, you will get the specific DTC numbers along with its the status of the fault to understand which fault has been set, whether it is set in active or history fault. And 1906 is for the extended information of the particular one fault. When I say DTC, it is a diagnostic trouble code for one fault, nothing but it is a one fault. One ID, one DTC is equal to one fault. So you can control this whether 19 service should provide the number of faults, like nothing but in the response whenever you get 5901 with the number of faults set, this you can control by using the 85 service. Nothing but what I when I say control, in the sense there are 15 faults in the system. There are 15 faults in the system, but you don't want to set these 15 faults the 15 faults are present in the system, okay, but you don't have to get the information of the 15 faults through the service 19. Even though fault are set, you can control whether these 15 faults should be provided to the diagnostic tool or not. That can be controlled by the 85 service. In the 85 service there are two functions, one is 01 and 02. So if you provide 8101, it is nothing but enable DTC control setting, nothing but whenever you read the 1901 02 06, you will get the how many number of faults have been set, what are the faults have been set, what are the other information of that particular fault. So let's say you have disabled the DTC by using the 8502. If you provide 8502, if you get the positive response 85 plus 40,
115.
sorry?
125. 120.
125.
Yeah, please convert that into hexa and tell me. Come on.
C5. C5.
Yes. C502. If you get the positive response like C502, then it is nothing but you have disabled the DTC control information which you are receiving whenever you read the 1901. So if you disable, even though there are 15 faults have been set in the system, when you read 1901 or 1902, there will be a no faults logged in. Nothing but you will get only 5901 and nothing, only 00, no faults logged in. Even though there are 15 faults present in the system. It is like controlling of the DTC setting in the 19 service. Clear? Hello?
Yes, ma'am.
So is it clear or any doubts? It is simple. Whether the faults, how many faults have been set in the system, it needs to be showcased you for you whenever you request by using the 19 service. If you don't want to get the information of the fault which are present in the system, you can disable it by using the 85 service 02 subfunction. So even though there are faults set in the system, if you read 19 service, you will not get any faults even though there are faults present in the system because you have disabled the DTC setting in the 19 service. That is the reason the name is called control DTC setting, where you can control to enable or disable the DTC setting in the 19 service, not in the system. Clear?
Yes.
Okay. So if it is clear, I'm moving on to the next service, which is 31. So 31 service is like routine control. Okay. So this routine control meaning, so let's say there are multiple functionalities, nothing but there are multiple features for one product. Let's say for the brake system. Okay, you guys have mentioned yours is ADAS project in that TSR, sign recognition, right? In this traffic sign recognition, there are multiple signs, correct, right? Like it could be speed limit, it could be, what else? Stop the car, no, I mean, wrong way, take the U-turn. Like there are multiple signs. Everything is one of the functionality if you consider as part of the software. If the the sense the radar or the camera is detecting this, once the software identified this signal, then what is the actual action should be taken care by the ECU. That is a functionality. Okay, this functionality will be can be done even by using the UDS services. Even it can be done by using the UDS services. So this is one of the functionality which I gave the example. So basically in your project, you will not do this by using the 31 service or UDS services. So usually you does unlocking the, that is security is 27. Okay, let me give in this way, this example. Brake. So you want to apply the brake. That will happen automatically inside the car. But as like suppose if you take your car to a service station and say that it is not, something is wrong with the brake ECU, so he has to apply the brake and check whether it is happening properly or not just by using the services. So how those functionalities, those are all called functionalities in a product. These functionalities, the practical functionalities, can be done by the UDS service, which is 31 service. In the 31 service is also called routine control. Here routine in the sense it's kind of a functionality, function control you can say it. So here we have three types of subfunction. One is start the routine, nothing but start the functionality. Another one is stop the functionality or stop the routine. Third one is routine result, get the routine result. Nothing but if you start one of the functionality, let's say apply the brake. How are we applying the brake? So 31, nothing but you are starting the functionality. So start routine 3101. So then how exactly that functionality is controlled? So for that, to control the particular functionality, we have called RIDs, routine identifiers. How we had the DIDs, data identifiers, for the 22 and 2E service. For the RIDs, nothing but for the routine control, we have the routine identifiers, where they have identified like F0, F1, F0, F3 or so on. I can show you the practical like how it looks like. The requirements. This is UDS, right? Hmm. See, FF01 is one of the RID here. So instead of this, I can show mine like Continental project itself. There it is used very much nicely. Hmm. I'll take some easy one. Pump check. Hmm. See, like this, as you can see here, AC01, AC0B, it starts from here. It starts from here. AC00 service bleed. AC0001, 02, 05, 06, 07, 08, 09, 08, 0B, 10, 11. Like this, you will be having a multiple, like see, all are RIDs. Up to here, everything is RIDs. Nothing but to perform the each functionality in a product, we will configure one of the RID with a name of like this. Like how we have the requirements based on that. So let me take one example of one RID which is ACE4. So this RID, by using this RID, what exactly we are doing? We are just releasing the actuators. So this is typically based on the brake ECU, where you guys, like anyone from mechanical background? Hello?
No.
No? Okay, fine. So what exactly happens? You guys must be knowing what is calipers. like which will be present, which will be connected to your wheels. So whenever it gets the inputs, so based on that these calipers only release and apply. Apply means it is applying the brake, release means it is releasing. That is what is meaning. So it is a one of the functionality in the brake system. So this is a one of the practical functionality which happens every day or like every time whenever you drive the car. So this function can also be checked by using the UDS service. How can it be, how can we can check this functionality, which is a practical functionality, by using the service 31. So let me open this. So whenever you mention 3101, the RID. So now the RID which we have considered is ACE4. When you start this RID will be configured for that one of the functionality. This functionality will be completely executed when you give this command ACE4. Okay, so what is that completely functionality? Apply like here, releasing of both the calipers. Yeah, release both the actuators, nothing but a calipers. It will be releasing both the calipers, only the left, like front, left and right. So how many wheels we have? Four we have. So each and every four will be having the calipers. Okay. So this functionality will be configured with the one of the RID. So the complete practical functionality can also be checked by using the one of the service, which is 31 routine control. So if you provide this command 3101 ACE4, nothing but you are expecting both the calipers should be released. That is what the functionality of this RID. Like this, there are multiple RIDs based on it, keep on changes based on the project to project, based on the functionality of your product to product. It is not constant. Okay. So if the functionality occurs nothing but if the both the calipers released properly, you will get the positive response, which is 7101 AC E4 and one of the byte, which is a status byte. This status byte is also keeps on varying based on the functionality itself, because this the status byte provides, usually it provides whether it is successful or failed or it is still running, the routine is still running. So this is the status of this functionality will be provided in this status byte, and this is not the fixed one. This will be keep on varying based on the functionality which you are executing. So that information will be already present in the requirement itself, because it keeps on changing for the requirement to requirement. So you have to see the requirement, understand the requirement, and then develop or test. Okay. So this is what the start of the routine control. So now whenever you're testing the functionality, of course you have to stop and then identify what is exactly it could be the behavior of the ECU. If you are stopping the functionality in between, so what exactly the behavior, expected behavior in the ECU, that also we can check by using the service 31 with the subfunction 02, which is stop the routine. So if you stop the routine, if you are getting the positive response 7102 ACE4, again this is a status byte, like whether you have stopped, nothing but user has stopped or automatically has stopped or any precondition did not met. So this type of the status will be provided in this status byte. Most of the project 02 will not be applicable. In some of the project 02 will be applicable based on your project which you are getting in. If it is applicable, it will be present in your requirement. If it is not applicable, also it will be present in your requirement stating not applicable. Okay, and then 3103. So once you done with your functionality checking, you have to check the result. So that is what is 3103. When you request 3103 ACE4, you will get the positive response 7103 and again with the status. This status could be if you have stopped in between the routine intentionally, you will get user has stopped the routine intentionally, or routine is not successful, routine is failed due to one of the reason. That reason will be present in the next byte. Okay, like when it comes to the 31 service, only fixed is 3101, 3102, 3103. After that, RID. After that, whatever comes in the next byte, it is not fixed. It keeps on varying based on the project to project or functionality to functionality. It is not even same for the every functionality in the same project. It will be keep on varying. That is the reason you have to analyze the requirement before you develop or before you test any of the thing in your projects. Let me just open one. Start routine, stop routine, routine require results. See, here whenever you request in the response 71 and based on your subfunction, it could be 01, 02, 03. So after that routine identifier, which is the routine identifier, in our case it is AC04, and then it is the status. This status will be keep on varying. That is the reason they have provided XX, because they are not sure. So when it is typically based on the routine identifier, nothing but which functionality you are going to work on. So you have to go to the one of the functionality. So now routine identifier is FF01. If see here, there is no next byte itself, there is no status byte. So here it is only applicable is 31, 01 and 03. That is the reason if the 01 is successful, then you will get the result like this 7103 FF01. That's it. Nothing but your functionality has been successful. There is no status byte. In the same way, if I consider another project ACE4, if I consider now, 3101 ACE4, which you will send the request. And then again here it is also not applicable 02, only 03 is applicable. So if you request 3103 ACE4, you will get 71, and the status is based on your request whether you started or requesting for the result. And then routine identifier, which is ACE4, which we have already seen, and here we have the status whether routine is running or completed or failed. This again varies. This status is not like, it is not same like this. It keeps on varying to 1 to 1. If I consider something like another routine which is used to perform some of the other functionality in the same product but different functionality, that time again it changes. Here it is same, but let me take another routine. Yeah. See here, now the complete status byte is completely different. So the status byte is typically based on the the functionality which you are doing by using the routine identifier. That will be, you will be getting based on your project itself. So I cannot say that it is a constant, because it keeps on varying based on the functionality to functionality in the same product, and keeps on varying based on the project to project. But this is how it will be. So is it clear? Hello?
Clear.
Okay. So now let's enter into the another functionality and also the reflashing sequence by using the reflashing sequence by using UDS. Okay. So what is reflashing meaning?
Sorry.
What is reflashing meaning?
I mean rebooting software, okay. Reinstalling software.
Rebooting,
Not rebooting, okay. Reinstalling the software.
reinstalling of the software. Okay, so why we do the reinstall or reflashing of the software? How are we doing it?
By using ladder batch.
Okay, what is that latter batch?
It's flashing of software to hardware.
Flashing of software to the hardware. I asked, what is that latter batch? I didn't like it is not only used to only to flash the hardware to the software to the hardware. It also does something else also. So first of all, what is that latter batch?
Hardware component.
It has a name. It's a hardware because you will connect practically. That is the reason you are calling it as a hardware component. It has a name, like how we have the microcontroller. It is also one of the hardware component. Correct, right? And whenever you are connecting the sensor or camera or radars, you are connecting directly into the ECU. These are all hardware components. If you're connecting CAN transceiver, and then what else is there? Memories, external watchdog, external EEPROM. Whatever you connect, everything is a hardware component. But everything has name, right? Microcontroller, microprocessor, like that. So what is that latter batch?
Exactly, that's I don't know.
Okay, it is called debugger. Okay, so it is called a debugger. By using this debugger, you will flash and then you will establish the connection between the like your software in your laptop to the hardware which you have connected. And then it is also used to perform the testing, which is white box testing. Nothing but as a developer, you will be using this more. Without this you cannot, you will write the code but you don't know whether that is working or not in the ECU. That will be done, that check by this debugger. Okay, which is, it is not only the ladder batch is a debugger for only one of the microcontroller. Like this we do have a multiple debuggers like renesas debugger, and also e1 debugger. Have you seen it, how it looks like? Because of course when you join the company, this is what you have to use it, this is what you have to get it from going to the someone's place, or you have to ask your lead, can I get the debugger? It's a hardware. This is how it looks. This is NXP1, that is the reason it is trace 32. Okay, so like this you have a multiple debuggers. See, this is even emulator. At the same time we have a like different one. You cannot say that I will use ladder batch only. You have to know why I'm using. So our project is my which microcontroller. That is the reason I'm using ladder batch. Clear? What I was actually telling. Reflashing sequence. Okay. So if you have it already the option to reflash the software by using the debugger, then why exactly we are gonna discuss the reflashing sequence by using the UDS? What is the difference between these two now?
Updating new installs, okay, new features.
Updating new features? No. Where are you updating new feature? You cannot simply update the new feature, right? I mean, you are telling it's right, but you are telling as a end user. what you will get it. You are not telling as a developer or a tester. Yes, come on, guys. Okay, so let's not waste the time. So by using the debugger, if you can flash, and you will be flashing by using the debugger only, because if your ECU doesn't have any software inside that ECU, nothing but the complete ECU, it's a complete new. Assume your microcontroller is completely new, so you cannot use the UDS services to flash the software or reflash the software. So by using the debugger only, you have to flash the bootloader and then the application and then the calibration. You will be flashing separate .elf files or the hexa files, which will be generated by you guys itself, who is a developer. Okay. So bootloader application calibration, you will be flashed by using the debugger. So, but for the testers or even for the developers, you have to develop a reflashing sequence by using the UDS. Nothing but whenever by combining all these three software, which is bootloader, application, calibration, or they will combine application and calibration and provide one package in the form of .elif file or hexa file. So when you get this, every time you cannot use the debugger, or every time you cannot flash by using the debugger itself, because it is required to flash by whenever the ECU is new or if you are having that environment at the same time. So why exactly we are studying UDS? This complete UDS is helpful whenever the car is already in the field. Correct, right?
Yes.
Yes. So do you really think whenever you want to reflash the software, or assume there was a bug identified and a new software has been implemented by fixing that bug and you have the new software to be installed. So that new software flashing, do you really think you can, remove the EC like car structure and then connect the debugger to your ECU and then connect the laptop and then open your all the IDEs. If you are using a NXP microcontroller, you will be having a trace32 as we have seen, and you will be connecting the lauter batch and then make the connection between these two along with your ECU and supply the power for that separately. So all these things you will not be doing once the car is in the production. Nothing but once the car is in on the field. You need something like a easy tool. Nothing but in your mobile, what is happening? You will just get a notification in the application called system update. Correct, right? So one nothing but that is the end user. End user can see only one notification and click on yes. Similarly, as a serviceman, what he will do? So he can reflash the software by using one of the tool, which is a UDS tool. By using one of the sequence. I mean, sequence he will not be knowing. As a developer, you guys have to develop that sequence. Okay, whenever he use, just add this file and click on reflash. That reflash should occur. It should reflash the software. How it is reflashed in the software and which sequence it has to reflash the software, it is up to the developer, not up to the developer, of course. It is up to the requirement, how the requirements are present. So by seeing that requirement as a developer, you have to create and you have to develop your code. It has to successfully reflash the software whenever it is reflashing is requested by using one of the tool. So at that time, all this debugger, your trace32 or latter batch, whatever the debugger is not at all required. Clear?
Yeah, clear. Okay, but I have to one doubt,
Yes,
not doubt,
please.
need clarification. Okay, what exactly means me trace 32?
It's a IDE. Like what exactly you guys have learned before coming into the Canon UDS?
I think no,
No, I mean you didn't have any classes before that. I know Lokesh used to teach something.
no. Actually, I mentioned test attitude in my project also. Okay, I mean in my resume. That's why I'm asking again.
That is okay. What is IDE?
I mean,
You guys have learned the C programming or not?
and
Sorry,
yeah,
Auto sir.
AutoSAR is not
I
yet
I okay. How about the C
complete.
programming?
Okay, AutoSAR, C program is complete.
Completed. So where did you execute the C programming?
Turbo C.
Turbo C. This is called IDE. For the C programming, you have used Turbo C IDE. For similarly, whenever you get into the company, you will not write any code with the C. You will be writing either embedded C or AutoSAR code. So for the embedded C programming, whenever you write the code, right, where how you have written the code in Turbo C, similarly, it is typically based on the microcontroller to microcontroller. If your project is using NXP microcontroller, then your IDE will be nothing but where exactly you will write the code. That environment will be Trace32 or Code Composer or what one more, like there are many with the C only. Trace32, Code Composer, Code Warrior, S32. Like this, there are multiple environment where you have to write the code. So typically your in when you your manager or your the complete product will be identifying this IDE which one to use it before itself. So you will be working on any one of this IDE, nothing but the environment where exactly you write your own code. And connect the ECU by using the debugger, and then set the breakpoint, and then run it and update your variables, update your code, and check how it is behaving, kind of a debugging. The name for all these things, it's called debugging.
Okay.
Okay, this is our kind of something basics. Basics in the sense, if you are showing you have a 6 months of experience also, you should be knowing all these things. Okay, so where we have stopped. Reflashing sequence. So now understood why exactly we are doing the reflash, why exactly you will be developing the reflashing sequence by using the UDS service. Yes or no?
Yeah, fine.
Okay. So whenever you are creating the reflashing sequence by using the services, there is a standard sequence. So everyone has to follow that sequence. The initially you have to enter into the default session and then to the extended session and unlock the security, depends on the level. 01, if it is 01, you will request the code and then you will send the 02. So after this, after you unlock the security, you will use the 31 service 01 FF00, which is nothing but by using this RID, you will be memory, erasing application and calibration memory. Okay, so 3100FF00 and the starting address of the memory and the overall size of the memory. It is typically depends on the project to project or product to product, because I will not be knowing which is the starting address and how much of memory address they have used in your project. So this information will be already given to you to develop your code. And for the testers also, this will be already present in your requirement. You have to, like, anyway you will not be providing when you reflash the software, you will just verify as a tester. But for the developer, you have to configure properly this memory locations. So for that your information, it will be present already in the requirements. So 3101 FF00 memory address, starting memory address and the memory size. So how many memory size you mention? Let's say assume you are mentioning 28 kbps. 28 kilobytes KB. So this particular 28 kilobytes will be getting erased from the starting address of 0001 if you are mentioning 001 as a starting address. So by using this RID, it will erase the memory based on your input, which will be always application and calibration. And if it is erasing completely, you will get the positive response 7101. If not, you will get the negative response 7F31 with the NRC code. Anyway, for the NRC code, we are still discussing more about the NRC code, which will be discussing more. So now no need to worry about the NRC, just worry about the positive response. So now clear about the FF00, what is happening? This is one of the functionality where we are clearing the memory. Is it clear? I'll open one of my PPT also. Yes. Here it has the normal one with the some random routine identifier. In this routine identifier only we have mentioned FF00 where it is exactly erase the application. See, like this you will be having it already. FF00 is the RID to erase the memory calibration data program. Here it is application. Okay, so once you get into the bootloader CDD, you will be having another set of requirements in the bootloader. So there you will be having the complete memory address information. That information you will get like this. So as of now, overall only C is over, is it? C programming.
Yes.
Yes, ma'am.
So here, see here, memory mapping. This is how you will get it. What is the size of bootloader? What is the size of calibration? What is the size of application? What is the size of RAM, EEPROM, and where it is exactly starts. So in our case, application and calibration, the size is 68 bytes of data and it starts from here. So starting address is this one, including 68 bytes of data will be present in this request. Clear now?
Yes.
And I can show one more thing also. Okay, fine. I need to search that. This is called for the 31 service. Anyway, we already discussed more about the 31 service. So I'm not uh, explaining bit more and again. And I mean, there is nothing to explain on that. So the next is once you erase the memory, nothing but there will be a nothing value on the memory. Correct, right? Nothing but that ECU doesn't have anything to perform anything. Okay, so initially you have erased everything, and then what you have to do? You have to download that erased memory completely. Okay, so to download that erased memory, you will be using a 34 service. Okay, so I'll just increase the this one so that you can easily see it. So 34 is the service where we used to download the memory which has been erased by using the service 31. So first you erased it and then you are downloading that complete memory location and then you will transfer the data and then you will come out. This is the sequence of the reflashing. So it is typically something like if you want to sit somewhere, what you will go there, and if some like you'll just make sure that place is clear. So you will remove the dust and then you will reserve that you feel that you have reserved that place to you because you have cleaned that place and then you will go in and sit. So here also same thing. You are reflashing in the sense what? You are reflashing the software completely, the application and calibration. What is the application software will be containing? The main functionalities. What is the calibration contains? We have discussed everything. What is bootloader application calibration and everything. So that information, like how the application should behave, nothing but in your TSR, traffic science recognition, the complete that all the signs is there, no, like 30 or 80 or wrong route or take a u-turn or y, everything. So all are signs only. So every information, like whenever it is detecting this sign, it has to do something, otherwise ignore at least. So what exactly issue, how exactly issue has to behave, that is the called a functionality of that particular ECU. So all those will be developed and kept in the application software. So if you are reflashing that application software, nothing but first you will erase it and download that particular memory and transfer the data. Nothing but how the software, how the ECU has to behave. That is what is present in the application software. That is what you are reflashing and keeping inside the memory again. It could be updated one, it could be the same one which you are reflashing. Okay, so do not think as an end user, think as a developer and tester. If you think as an end user, you will not understand. Get it? Getting it?
Yes.
Yes. So by using the 34 service, 34 and the next byte will be data format identifier, which is nothing but in the request 00 to FF, nothing but. So here in usually it will be 00. So for example, I'll open the real one. So here 00 in the sense there is no security for this. Whenever you are downloading, you are not asking the permission from someone. Usually it will be 00. That is the reason. If I have not worked on a project where it will be something else other than 00, where they provide or encrypt this particular request. Nothing but to download the memory also, it will be encrypted if this particular byte is other than 00. I have worked on only 00, which is this particular function, which is a downloading of the memory is not non-encrypted. Okay, so usually it will be 00, 34, 00. And 44 is address and length format identifier, which is nothing but 4 bytes of data is present for the next 4 bytes is for the memory address and other 4 bytes is for the memory size. Since we have the 4 bytes and 4 bytes, this is the length of this. The same thing we are mentioning before itself. The next of this byte, I have the 4 bytes of length and 4 bytes of length, which is belongs to the memory address and the memory size. That is what is the length data identifier, and it is fixed. 34, 00, 44. It is fixed. What is varies? The memory address, starting address and the size which you want to download, which with the one which you have already mentioned in the 31 surveys. The same address and the size you will be mentioning over here because you have to download the same memory with this much of size. Clear?
Yeah.
Yeah, so if you send this request to the ECU, of course ECU has to respond positively or negatively. So now we are discussing only positive. So whenever ECU is responding positive, nothing but 34 plus 40, 74. So nothing but it is a positive response. The next one is length format identifier. Same like this, how we have the address and length format identifier in the request 44 where it is mentioning that the next is 4 bytes of data plus 4 bytes of data. Similarly, here also it is as a length format identifier where it is mentioning 02. Here do not confuse. This is also a fixed. This is never gonna change. Okay, this is from the MSB. That is the reason you will see instead of 02, you will see 20 always. So this is a length format identifier where it is mentioning the 2 bytes of data are present next after me. Okay, that is what is mentioning the length format identifier 02. So what is the 2 bytes of data will be containing? We will come back once we discuss the 36 service because that's where you will understand what is this block. Okay, so now again, so I'm just repeating again. Once you erase the memory by using the 31 service, you will download the same memory. You will download the same memory. While downloading, you know how to request it. 340044 memory address starting and its size. So this is what the like it is fixed. It is not going to change. If there is any encryption, then only it is going to change and it would vary till FF to FF, 00 to FF. I have seen only 00 because it never encrypted. So the next one is 36. In this 36, nothing but once after you downloaded the memory, you will transfer the data. What is it data you are transferring? If you will be generating one of the .hex file or .elf file. Okay, so by using these two, what is exactly containing? Whenever we say transferring data, what does it mean? How the data is present. You cannot, of course, we are not saying the ECU to simply, okay, ECU, now there is a signal, there is a sign called, you are going in a wrong way, wrong route, you have taken it, just come back and again go on a right route. We cannot say like this, right? It has to given by the camera, and camera is also not saying this way. It is providing the data. What is the data? And if it is providing the data, how our EC is understanding? That is called a software, right? That is what will be done by the software developer. Correct, right?
Correct.
So what is that meaning? Transferring data means, what is it meaning? How your ECU has to behave. That is what you are saying to the ECU. As a developer, you are developing how the ECU has to behave. If something is happening like this, how it has to behave. Because that is not a human. That is a just electronic device which will be controlled by like developers. So how the developers write the code, that is how it behaves. Otherwise, it will stuck somewhere and it will not give anything. Correct, right? So now what is the data? Transfer data is nothing but in the hex file, in the .elf file, you will be having a memory address and also the data on every memory address. The data means what? Some hex values 0, 1, 3 or E0 or E1, like anything like this. What is it meaning? How the ECU will understand like this? This file will be generated by using the code which you have developed inside the trace 32. In while writing the code inside the trace 32, what you will write? You will write if or else condition or function call, whatever. You will be having a nearly 1 lakh of lines of code for this particular ADAS ECU. So you will not use that code. First of all, you will generate the X file or .elf file where it will be like this. It will be having a memory address, each and every memory address. For each and every memory address, there will be some value like 01, E0, E3, whatever the value, and every memory location. This is whatever the code you have written, it will be converted into this. And this file only you are going to flash or reflash into the ECU. Nothing but in the reflashing sequence, first you have make sure the memory wherever it has to get flashed, it is empty. Nothing but you have erased. And then you have downloaded that particular memory. And now transferring data in the sense, as I told you, that memory address and the memory data, the values or data on the every memory will be transferred into this particular memory, which like how we have mentioned, you have mentioned in this, right? So Microcontroller, what is that? It will be containing a memory inside this. Inside that, if you are keeping the data inside that memory only, it is going to understand, okay, I have to behave in this way. Otherwise, it won't understand. So every data will be transferred inside the memory, whatever you have downloaded. So of course, you cannot transfer the data completely at a time. That is the reason you will transfer the data block by block. If you have learnt the C, you will be knowing what is this block by block. Otherwise, how the block will be. So everybody knows what is stack, right?
The stack or stack overflow.
Stack overflow is different. Stack. What is overflow? It's a scenario. If you are trying to, give the more memory value on the memory address, nothing but your memory, you have only 3 bytes of data, and you are trying to add the data of 6 bytes of data. That time it will be overflow. That is a scenario or situation. I am just asking stack.
Yeah, okay. It's following like a linear follow.
Okay. So anyway, so this is how the memory will be, and the data will be transferred into the memory block by block. So whatever we have seen in the response of the downloading, here you have seen there will be a 2 bytes of data, which will be a maximum number of block length. Nothing but in these 2 bytes of data, you will be identifying how many, not you, ECU will be identifying how many blocks of data it gonna transfer. Nothing but what is the maximum block it can separate. That block information will be present on this 2 bytes of data. And then the what I said, that it will, the data will be transferred block by block. That will be transferred in like this. So 36, anyway, it is already opened. 36, see here, block sequence counter. So it will start with the 00 and end in the FF. And all the data will be transferred, like this is a data. It could be 01, E0, E3, F1, F2, like based on your code. And based on the whatever you have written, thousand of line, whatever you have written. So everything will be converted into the EXA file. That file, whatever you have, will be flashed inside the ECU. Then it will be converted into the binary, and it will be transferred into the microcontroller, and then it will be understand this is what I have to do. Okay, so this is like the sequence counter. It will be keep on changing like 3600 and transfer the block, that much of block of data, and then 3601 and then transfer another block, 3602 transfer another block, 3603 04 05 06 07 08 09 010. Like this it will keep on goes up to FF. Okay, so it is not constant, again FF, based on the in your project what is your maximum number of block length. Based on that your sequence counter will be identified. Clear? For this transfer there is nothing, it is only the positive response will be 76 plus 40 to the 36 and its sequence counter. That's it, nothing else. If it is getting negative response, nothing but data is not transferred. If it is giving the positive response with the 76 and the block sequence code, which block sequence counter? You are in a 06 or 07. So for every sequence counter, you will get the positive response. So if you are getting positive response, nothing but your data has already gone to the memory location and updated in that memory location. Clear?
Yeah.
Okay. So the next one, the last one is 37, which is a transfer request to transfer exit. Nothing but you have been transferring the data block by block. That type of block will be like 40, 50, 60. It keeps on changing based on the criticality of your project. Nothing but based on the, if you are working on a ADAS, it will be having a very more, more number of software lines of code. Of course, at that time you will be having a more, the software will be high size of data. That time the memory will be more, nothing but the data should be the data which will be presenting or placing inside the memory will be more. That time you will be transferring. So once it is transferred, you want to remind the ECU to come out of that. That is what will be done by the 37 service, which is request the transfer exit. Just exit from the request transfer request, which is 36 service. You will just request 37, and then if you get the positive response of 77, it is done. Nothing but you have come out of the request transfer which has been done by the 36 service. And also in the 37 service, it will calculate the checksum based on your address, nothing but based on the starting address. And one algorithm will be used, that is typically changes by using the algorithm or the polynomial formula, and the input will be your memory address. By using the memory address, it will calculate the checksum, and it will place in these 2 bytes of data. If and at the same time, inside the ECU also it calculates the same checksum. If this checksum and that checksum inside the ECU, if both are same, then only the reflashing of the software it's complete. Otherwise it's corrupted. Nothing but this is not the valid application file which you have flashed it, which can be compatible with your microcontroller. You cannot simply flash every software like whatever you develop on any other ECU, right? So in your software as a developer, you will be configuring which microcontroller you want to use. In that microcontroller, which family. In that family, what are the features you are using, which are the timers you are using, which are the counters you are using, which are the memory you are using. Everything you will be configuring it. So based on that, it will calculate the checksum. So if the checksum is proper, it will give you like the application software or calibration software will be successfully flashed inside the ECU, so that it will start behaving how the how you have coded the software inside the microcontroller. Otherwise it will be corrupted, so it will just go inside the one of the infinite loop or stuck somewhere in the one of the line of the code. So it will not execute every line of the code in a sequence. At that time ECU will not respond. Okay, because like ECU will not respond in the sense it will go to the bootloader and it will not provide any output, nothing. But if it is in the bootloader, we already know it will not perform the main functionalities. So it is like a kind of you have to reflash the application again, because you have flashed the corrupted application or invalid application which is not supported by the ECU. Clear?
Yeah.
Okay, so this is all about the reflashing sequence of by using the UDS. Can anyone tell me one by one? Service 10? Just service is enough. Sorry?
Session controller.
Service 10. Then sequence. I'm asking about the sequence of reflashing by using the UDS. Yes, come on guys. $27.
34, 36.
31, 34, 36,
37.
37. So once the checksum is proper, nothing but it will give you the ECU will start providing the output, nothing but TX frames, and after this automatically 11 will like hard reset will be taken. Okay, this is the sequence of the reflashing by using the UDS. Clear? Hello, is it clear?
Yes.
Okay. So I have left out with a few more topics and even the negative responses. Let me complete one by one. Okay. So S3 server timer. So to understand S3 server timer, I want to explain another service which is 3E, which is called tester present. Okay, so what is it meaning of this tester present or 3E service? So typically, okay, so whenever you are in the as we already discussed, by default ECU will be always in the default session. So if you want ECU to jump into the application, then you have to request the service 1003. Nothing but you are telling the ECU enter into the application. And if you want to enter into the bootloader also, you have to request 1002. Then only it will enter into the bootloader, irrespective of the whenever it is application is invalid, or your software is stuck somewhere, or a sequence it is not executing a sequence, or any watchdog failure fault, any microcontroller failure fault, automatically it enters into the bootloader. But intentionally, as a tester or as a developer, if you want to enter into the bootloader, this is how you will enter into the bootloader, by requesting 1003 to the application, 1002 to the bootloader. So now, whenever you request your ECU to enter into the application or bootloader, what do you think? How long the ECU will be present in the application? What do you think? How long ECU will be in the application? Once after your request or your ECU entered into the application?
1 microsecond.
No. So as per the standard, it is 5 seconds. As per the standard, once you request enter into the application, ECU will be inside the application for 5 seconds. After that, automatically ECU will go back to the default session. So in this case, as a developer or as a tester, you want to to test or some of the scenarios, or as a developer you have to develop this. So once the ECU started performing the main functionality, ECU has to be in the application for longer time. Correct, right? If it is just going back to the default session, then main function, how the main functionalities will be done? It is not possible, right? You have to develop your the software in this way. So after the 5 seconds, again it will go back to the default session. This is a standard. You have to develop in this way itself. After the 5 seconds, enter into the application, or it could be bootloader. It has to go back to the 1001. Nothing but default session. Assume you are flashing something, and then after 5 seconds, it will go back to the default session. Do you really think the flashing will be continued?
No.
No. So there should be a solution for the same, right? To maintain the ECU in the same session for longer time. Correct, right?
Yeah.
So for this purpose only, we have the something called tester present, which is service 3E. Whenever you request 3E00, this is the just a request, like 3E00000000. 8 bytes of data of 000000. This is called a tester present. Whenever you send this service, if you are getting the positive response of 7E00000000, 8 bytes of data of 00s, nothing but you can make your ECU present in the same session for longer time. But you have to send this 3E tester present periodically. So what is mean by periodically now? Let's say in a general, after how many seconds it will go back to the default session?
5 seconds.
5 seconds.
5 seconds. So if you are sending your 3E service at least at 4 seconds, then ECU will be in the same session even after the for 9 seconds, correct, right? Anyway, 5 seconds is a standard, it will be there. After that, one time you are sending 3E service, so it will be like after 4 seconds, nothing but after the 5 second or at 4 second you will send the 3E service. So your ECU will be on the same session for 8 to 9 second, and then again it will go back to that 01 default session, which you don't want. So to continue having the ECU in the same session, periodically you have to send the 3E service. Periodically in the sense, kind of 4 second, every 4 second, every 30 second, every 2 second, every 1 second based on your request. Okay, this is called like if you are sending a one message every sometime, like your TX messages from the ECU. So ECU will be responding output. Do you really think ECU will respond once and then stop responding the providing the output? It has
No.
to keep on providing the data, right? Based on the like every 1 millisecond or every 2 millisecond, every 5 millisecond, every 10 millisecond. ECU has to keep on providing the output. Correct, right? Similarly, you have that is called a periodicity. How often ECU has to provide the message, or how often you have to send this tester present. You have to send this tester present periodically. It could be up to you. It could be 250 millisecond you can send it, 4 second you can send it, 3 seconds you can send it based on the test scenario. If you what you want to perform and how long you want your ECU to be present in the same session. This is called a tester present. And this 5 second where ECU will go back to the default session once after the 5 second. This 5 second is called S3 server timer. S3 server timer. Is it clear?
Yeah.
Okay. So if it is clear, I'll just come from the beginning. If something is missed out. Okay. So the one topic is which I want to discuss is physical address and functional address. It applicable even for the CAN protocol as well. We already know what is IDs, right? Anybody? What is identifiers?
Like we will give for certain ID for like for right camera, left camera like that. Okay, we will give some identifiers, right?
That is on CAN. Very good. So how about in the UDS? So how we used to write the request first of all initially? We used to write identifier and then DLC and then we started with the service, right?
Yes.
Yes, what is this identifier?
Like service number, right?
Service number?
Request ID.
Request ID. Very good. What is that request ID meaning? So how in the CAN protocol you have the for right camera, this is the identifier to identify it is a right camera. And for the left camera to identify it is a left camera, how you have the identifier. Similarly, ECU will be responding if you, like it will not simply respond if you request 1003 and with any tool. No, that identifier should be configured inside the ECU, which is the identifier of a diagnostic tool. If it is configured inside the ECU, if it is acceptance criteria, which we have seen it, if it is accepting, then only it will respond. Otherwise, ECU will not respond. This is the like for every tool, it should have an identifier. That's how it will be known by the electronic devices. Otherwise, it will not even identify it. Correct, right?
Yes.
Yeah, that is the identifier. We have it in the UD diagnostics. Okay, so now when we comes to the physical, in this IDs itself, there are two types. One is physical IDs, nothing but identifiers. Another one is functional identifiers. When it comes to the physical identifier is something like the specific. You are saying in the UDS how we used to say, let's say you are controlling this particular ECU with the one diagnostic tool. As a diagnostic tool, in the identifier, how it what I we already discussed this also. If the identifier is like 173, what does it meaning? This is the request identifier 173. What does it meaning? What is 73 tells? We have already discussed this. It's the destination address, right? Where you are like as a in the by using the diagnostic tool, you are requesting the particular ECU. You are not requesting simply on the send the request on the bus and whatever the ECUs want to respond. No, you can validate one ECU at a time. So that is the reason what you will mention. This identifier is the like for this ECU, this is the identifier. 73 is the name of this ECU. What it happens, what it is exactly doing, whenever you are requesting a diagnostic tool, you are saying I am trying to access particular this ECU. Correct, right? We have already discussed what is 73. In the 29 identifier, what is this and what is this?
F1 is the source ID and
Destination ID. Very good. So, okay, you guys are remembering. Fine. So in the this is called a physical identifier, which is a 173 because you have mentioned which ECU you want to identify. Nothing but it is a specific communication between the diagnostic tool to the ECU and ECU to the ECU. Okay. So then what is the functional identifier? When it comes to the functional identifier, let's say example you are mentioning 075. Okay. So when if the functional identifier 11-bit identifier functional identifier, if it is this one 075, then this is not the specific address of the ECU. So this is something like in the functional identifier, if you are using, you are not trying to access the one particular ECU. What you are trying to do, you will just send your request with the functional identifier. It is like kind of you are broadcasting your request. Whatever the ECUs, how many ECUs are present in the like connected in the network, every ECU which is having the acceptance criteria for this particular functional address will respond back to you. Not only the one specific ECU, you will be getting response from the multiple ECUs. So this is what is called functional IDs, which is like a broadcasting of the messages on the bus, not to the specific ECU. In the physical identifier, you are requesting a information from the specific ECU. So this is the purpose. Whenever you request the information from the ECU by you for the in the UDS protocol, you will not receive the response from the ECU, but that functionality will be done inside the ECU. This is a requirement. If you are requesting any request like 1003, if you request with the functional identifier 075, then ECU will not respond positively, but the functionality will be done, which is it is entered into the application. But not only the one ECU. So as a developer or as a tester, you will be testing only one ECU. That is the reason you can see the request and response for one ECU. But in practically inside the car, it will be having a multiple ECUs. So that time if you broadcast one single message into the network, multiple ECUs will be responding. But as a developer, as a tester, you will be working only on one ECU. That is the reason you can see the request and response for only one ECU. But in practically only you will get to know how to use the functional IDs, but which you will be not working in practically. That will be done by the vehicle testers. This is what is called physical identifiers and the functional identifiers, where so the physical address, as it says, it's a point-to-point communication. Nothing but you are trying to communicate with the one specific ECU. By if you are sending it a request with the functional identifier, it is like you are not targeting one ECU. You are just broadcasting your request. It will be addressed by the multiple ECUs or group of ECUs in the network based on the acceptance criteria of their network. Clear?
Yes.
Okay. So this also we have discussed. 4905 discussed. Multi-frame discussed. This also we have. Okay. Negative response only left, is it? 31. Okay. Service 10, 11, 27, 28, 85, multi-frame, 22, 22, 2E, 2E, 14, 19, 19, 31, 34, 36, 37, P2, P2 star, S3. Okay. So we have it only the negative response left out to complete it. In that negative response, we already discussed for service 27, which is very much important. All other negative responses will be general for every services. Only specific is for the 35, 36, 37 for the 27 service. 30, don't confuse with the service 35, 36, sorry, 36, 37 and with the negative response 35, 36, 37. Again, you have one other negative response called 31. So do not confuse with the negative response codes with the service codes. Okay. Okay, fine then. So the remaining negative responses tomorrow we'll have half an hour class and then it will be over. So please do let me know any doubts in the tomorrow's class because tomorrow class would be the last class for CAN and UDS.
Okay, fine.
Okay. So any doubts? Anyone, any doubts on anything? Okay. So one suggestion from my side, whenever you go to the work in the company, so if it is a online or if it could be work from home or work from office, but read your resume properly and understand whatever you have mentioned in your resume, everything properly. That's what is important because sometimes uh, they mean they simply nobody gives the KT. They will ask what did you work on, so that they will understand how much they want to teach and how much they want to skip. Okay. Okay, fine then. Thanks everyone. Bye bye.
Thank you, ma'am. Good night.
Thank you.
Good night.